Okay, so we're going to start looking at, kids, everything I talked about over here. I think you understand what we talked about here, what we talked about here, and what we've talked about right up here, okay? Dividing and multiplying rational expressions here, all right? The question becomes, how do we determine what an excluded value in a product or quotient of two rational expressions would be, okay? This is a really fancy question today for saying, find stuff that cancels. Okay, look at this example right up here. What was going to cancel in the one I wrote on the board up here, kids? The x plus 1s are going to go away. Okay, do you agree that negative 1 would make the denominator 0? Right here, the way it's written. But if I can make that go away right away, if I can make those go away because they cancel, does negative 1 make that 0 anymore if stuff cancels? The answer is no. So when we talk about dividing and multiplying rational expressions today, and they ask the question, how can you determine I'm going to underline this, the excluded values in a product or quotient of two rational expressions? What they're really asking you to do is to say, or they're really saying, in rational expressions, this is what they're asking you today. What cancels? And we're going to show you how to simplify products and quotients of rational expressions today. And I think that you're going to find that even though it looks difficult, I think you've got enough background knowledge to be successful. You're going to be like, Parsons, is that all we do? And I'll be like, yep. And you're going to be like, oh, well, this is pretty easy. I think that's what's going to happen today. Okay? Now, I could be wrong, but you guys are pretty on the ball with stuff like this. Ready to proceed, kiddos? How about some goals for me today? What are we trying to do to figure out how things cancel in rational expressions? What's the first goal, kids? Simplifying stuff. Isn't canceling part of simplifying stuff? Make things cancel? Simplifying? It is. Okay, and then really, how do you multiply rational expressions? How do you divide rational expressions? Again, when I talk rational expressions, the word rational, think what? Fractions. You got one polynomial function over another. All right? Let's get some definitions accomplished, and we're going to run through this so quick today. You guys are going to do awesome. I know you are. Rational expressions here. Read it for me, somebody.
A rational expression is a fraction whose numerator and denominator are non-zero quantity.
Okay, so it's, as an example, you might have like 3x squared plus 6x minus 7 over, I don't know, 4x squared plus 10x. All right? That's an example of a rational expression. Now, simplified form of a rational expression occurs when the numerator and the what? Have no common factors other than what? Okay, watch this right here. I'll give you an example. Suppose I have, I don't know, you're going to see stuff like this. We're going to get to a point where we have something like x plus 1, or I'm sorry, x plus 2 times x minus 3 over maybe, I don't know, x minus 5 times x plus 2. Simplified form will occur when there's no common factor other than 1. And as I look at the top and as I look at the bottom, both the polynomials in the numerator and the denominator are written in a factored form. And as I look at factored form on top and factored form on the bottom, are there any quantities that are the same? What would be the same? What are the x plus 2s going to do to each other? They're gone. So what would simplified form of that be then in the end? X minus 3 over x plus 5. You're going to be looking for common things to cancel today. That's how you answer that question up there, the essential question. That's how you can determine what's excluded. There's some vocab in there we know already. You know what a fraction is, right? Okay. A over B. That's a fraction. Numerically or expression-wise. 3x over, I don't know, 7. It's a fraction. Okay? Fractions are like rational functions. You know what a polynomial function is, right? Polynomial example. 3x squared plus 6x minus 9. What degree is that polynomial? Second degree. Highest power is 2. The domain is all values of x. X values. Sometimes we call it the input, so that's a background knowledge that we need to talk about. Equivalent expressions. Yeah. Isn't 2 plus 2 equivalent to 3 plus 1, kids? Are those equivalent expressions? Because 2 plus 2 is what value? And 3 plus 1 is what? Equivalent expressions. So we're going to talk about what equivalent expressions are. We're going to look at it in terms of variables. So I'll show you what that is. Anybody misses reciprocal, I'm going to tip you upside down. Oh, come on, that was good. What is a reciprocal? Yeah, reciprocal of x over y is what, kids? Y over x. Okay? If you don't know reciprocal, I'm going to tip you upside down. Crazy thing. I told him I would lay off the coffee too. Let's roll. Simplifying rational expressions. There's some rules about simplifying rational expressions. I've got to make sure I get them in order here. There's 3 of them. Give me a sec. Okay. What first rule they put up here, kids, is this. AC over BC. What would that equal, kids?
A over B.
A over B. Okay, another example here that they used that was really good. So maybe I have 15 over 65, kids. Maybe it's numerical. What would factor out of both of these? What values?
5.
So this is really the same as 5 times 3 up here, right? And isn't 65 the same as 5 times 13? What do the 5s do? So an equivalent expression to 15 over 65 would be what over what? 3 over 13. Maybe I have something like this. 5, I don't know, x plus 10 over x plus 2. Okay, think of your top, 5x plus 10. Is there anything you can pull out of 5x and 10? I can pull a 5 out of the top here. So the top would become 5 times what? All over what? So what are going to happen to your x plus 2's here? Okay, so these are some examples of simplifying rational expressions. So let's roll on this. First one I have up here, simplify the following rational expression. Make this easy as possible. It says x to the second minus 1x minus 12. Okay? So what we need to do is a lot of factoring. Simplifying rational expressions, we're going to have to get back to factoring days. Now, I know that this is something that's tough on you guys, and I don't think that we practice it enough at Union High School, but by golly, we're going to get some work here. So guys, really, this is x squared minus how many x? Okay, so let's work with this. Can you guys think of a way to factor x squared minus 1x minus 12? In other words, can you think of two numbers that multiply to negative 12 and add up to negative 1? And again, what I like to do is just think, I was like, all right, well, factors of 12. I'm going to list them over here. 1 and 12. Is there any way 1 and 12 make negative 1? Oh, I'm hearing 3 and 4? 3 and 4. Okay. How do 3 and 4 make negative 1? And I should talk about in terms of sum. Negative 3 and positive 4? Positive 3 and negative 4 is what you want. Okay, does positive 3 and negative 4 make negative 1 in that middle term? Does the product of 3 and negative 4 make that negative 12 on the end? So you're telling me you want positive 3 and negative 4, right? So this top would factor into x plus 3 times what? All right. How about the bottom? X squared minus 9. This is one of those rules that's the difference of two perfect squares. How many x are really in the middle there, kids?
0, 2.
It's like 0x in there. Isn't this bottom the same? Isn't the bottom the same as x squared plus 0x minus 9? Isn't that the same thing, kids? So factors of 9 that somehow add up to 0 and multiply to negative 9 at the same time. Yeah, positive 3 and negative 3, right? X plus 3, x minus 3. Think about it, kids. You guys agree with the factoring there? What's 3 times negative 3? Negative 9. How about negative 3 plus 3 here in the middle? As I look at what I've written in factored form, what do you notice about the numerator and the denominator? The x plus 3's are going to do what to each other? They're going to go to war with each other, and they're both not coming out very well, right? What's going to happen to the x plus 3's? Cancel. We've excluded them. What does this simplify to, kids? So I have a question. The way it was written right here, they'd say, hey, negative 3 is a 0. I'm going to say, no, it's not, because they do what to each other? And the same expression is x minus 4 over x minus 3. Woo! Okay, I'll stop. I think that's exciting stuff. Kiana's looking at me like I need to get a life. And she's probably right. Kiana, do I have a life if I'm going to the Hawkeye game tonight? Okay. I'll go hang out. Yeah, I'll go hang out with the cheerleaders and I'll go out the court and kick around. How's that sound? Try a backflip.
How do you feel about that game Monday?
Oh, it was terrible. Tuesday. That last play, they've got to get to the basket.
They're still like,
Well, they are, but I mean, seriously, they had a chance to win again, and but the play call was horrible. Get to the basket. You don't shoot a 3 with someone in your face. You got to get to the basket and hope you get fouled.
it worked the last year.
I know it did. I know it did. Luckily, it worked the last 2 times. They shouldn't have even been in this situation the last 2 times. Let's put it that way. I'll give it that Maryland's a decent team, but you still got to get to the basket in a situation like that. Okay, that's on McCaffrey.
He wants to do UNC.
No, but I heard. All right. Hey, basketball aside. Multiplying what? When you multiply fractions, kids, you multiply the tops and you multiply the bottoms together. So let's talk here. Guys, I have a coefficient 6 and 9 right here. What's 6 times 9 going to be? 50 what? Okay. And how about your x's? X to the second, x to the fifth. What would that be? X to the 7th. Y to the what up top? How about on the bottom? What's your product in the bottom? 6 x y to the 4th. Let's talk, kids. What's this going to simplify to? Okay, let's look at the 54 to 6 first. Can 54 to 6 be reduced to what? 9. Would the 9 stay up top or go on the bottom? Okay, this is 9. Are there more x's up top or in the bottom, kids? How many more x's are up top than in the bottom? So this 1x is going to make this exponent of 7 a what? So this becomes x to the 6th. Okay, I'm buying what you're selling. How about the y's, guys? How many y's are up top? How many are on the bottom? 3 up top would take 3 out on the bottom, leaving you with 1, but where? On the bottom. Okay, there's more y's on the bottom than on top, so the y's have to stay where? And there's going to be how many y's down here when I put these together? 3 of these would take out how many down here? 3 of these, making that a 1. There's your simplified form. 9x to the 6th over y.
So if that was like a negative down there when you did that, would you want to bring the y up?
You could. If you have negative exponents, move it to make it positive. You always want positive exponents in the end. Okay? Let's make life simple. You ready to roll, kids? Okay, you get this multiplying example right here, right? But when we start multiplying, not stuff as simple as this, we've got some pluses and minuses in the product. This is where you're going to want to start to try to factor some things. Okay? So take a look at this top left part right here, kids. Can you factor anything out of 5x minus 5x squared? Okay, so the top left, this is really the same as 5x times what, kids? How many times will 5x go into 5x here? 1. Minus what? I agree. Okay, then let's do the bottom here. Numbers that add to 3 and multiply, multiply to 3 and add to negative 4. Can you think of them? How about negative 1 and negative 3? Does that work?
Yeah.
What's negative 1 times negative 3? What's negative 1 plus negative 3? So on this bottom left, do you agree that this factors into x minus 1 and x minus 3? Would you agree with that? Okay. This is going to get really tricky here. You agree with the factoring so far? How about this one? What adds to negative 5 and adds up to, or I'm sorry, what multiplies to 6 and adds to negative 5? Negative 6 and positive 1 would add up to negative 5, but that multiplies to negative 6, doesn't it? Negative 2 and negative 3 would work, wouldn't it? So I'm going to call this x minus 2 times x minus 3 up here. And then can I factor 5x at all? Answer is what? No. All right, kids, watch what happens when we want to multiply this mess out. What does this 5x do to this 5x? Gone, isn't it? Anything else that's gone? Okay, there's a part that I want to talk about and make sure we're very clear on. It actually has 1 minus x and x minus 1. Are they exactly the same thing? Let's talk about this. Suppose I had 1 minus 5 and 5 minus 1, kids. And they were over each other like this. What would 1 minus 5 make? What would 5 minus 1 make? Which would be what value? So when you have something like this with a minus sign there, if you have 1 minus x and then you have just the opposite of that, x minus 1, they're going to actually turn out to be what value? These two are going to cancel out to be negative 1. This whole left side really is negative what? 1 times what's left over here. So if this becomes negative 1 times x minus 2, gosh, that negative 1 is going to make the x what kind of a value? And that negative 1 would make the negative 2 a. So what's this going to multiply out to in the end in simplest form? You would say negative x plus what? Oh my gosh. Guys, you're really looking to factor things and see what does what. Factor stuff, see what cancels. Factor stuff, see what cancels. Factor stuff, see what cancels. What's our slogan for the day? I'm going to turn that into a rap. Factor stuff, see what cancels. You guys are looking at me like I should just keep on teaching and quit rapping. Okay then. I like constructive criticism. Won't waste time on my rap album. Is that okay, Gavin? Okay. How many would buy my rap album about mathematics?
Oh, yeah.
Oh, it'd be so cool. We could get like the little, what do they do now in rap songs? They got the little, I can't even make the sound. People in North Carolina might get offended, huh? We have a tricky one right here, an example 4. Kids, I'm going to put this up on the board. Remember the rules for factoring perfect cubes. Okay, good. Neither do I. Do you guys see the x cubed plus 8 down here? Okay, factoring perfect cubes. You might want to jot this down right up top. I'm going to put it up here maybe. X cubed plus a cubed, or minus that, like so. This is going to factor into the following. It'll factor into x plus or minus a times x squared minus plus 2ax plus or minus a squared. I'll show you what I mean by this. All right? See how I put this minus plus sign up here, kids? If it's a plus, keep the order same here. You see what I'm talking about? But right here, what happens to it? If I have a plus here, what side am I going to choose here? Minus, right? You okay with that? Okay, just jot that down. It's a mess, I get it. All right, multiplying a rational expression by a polynomial. Anytime you have a polynomial, do this. Take this polynomial, let's put it over what value? 1. Okay, so we've got one fraction times another fraction. Can x minus 7 be figured to be reduced at all? Can you simplify x minus 7? No, leave that as is. Okay, here comes the tricky one. X cubed plus what? Okay, 8 is a perfect cube. What number times itself 3 times makes 8? 2. Okay, so we're going to use this up here. This is going to become x plus what first? In factored form, x plus 2, then it becomes the following mess right here. X squared minus what? 2 times what? A, so x squared minus what's 2 times your a value of 2 that we're using? So minus 4x plus a squared, which would be what? 2 times 2, right? Oh. Because it's opposite of that one sign. There's just a factoring rule that's up there. Okay. If it's plus minus, like we have x cubed plus 8, right? So that first quantity is going to be x plus 2. And then no, I've got something wrong here. I'm sorry. This should just be ax right here. Ow! Did you hear that one? I saw light on that one. This should be ax. So back here, this -4 should be -2. My mistake. Okay, and then this is times what, kids? Ooh. Kids, anything you notice? This whole thing does what to this whole thing? Anything else cancel? What are you left with? X minus 7 over what? That one's tough. That one is a tough one. I want to make sure you have the rule written down up here for cubes again, okay? So for your cubes, this should be if you ever have x cubed plus a cubed. And again, what was the a value we were using right here? What number times itself 3 times is 8? Or what's the cube root of 8, in other words? 2. Okay, this becomes, that's a 3 right there. This becomes the following. It becomes x plus a times x squared minus ax plus a squared. Now kids, if this was a minus sign right here, what would you do with all these signs right here?
Flip.
In other words, if this was like x cubed minus 8, then what would you do with all the signs here? You would just do what? Change them, right? Okay. All right, so let's try example 5 here. Guys, example 5 says find the what? Quotient. Okay. When you divide by a fraction, it's the same as what? Multiply by the what? So we're going to do one together, and then I'm going to have you try one. Multiply by the reciprocal. So the left side is going to stay the same. It's going to stay 11x over what, kids? Well, let's talk about that 3x minus 9 here in a little bit, all right? But we're going to change this not to division, but to times what, kids? Over what? Okay, anytime you see division, what are you doing, kids? Multiply by the reciprocal. All right, let's chat. From here, 11x. Can you simplify 11x up there? How about the 3 times x minus 9? Anything you can factor there? What could I take out of 3x and 9? So this would be 3 times what, kids? Okay. Can you guys think of 2 numbers that add up to -8 and times to positive 15? Got it? I hear -5 is 1. -3. If your order on these quadratics ever goes, you got a middle term which is a minus and then plus out here, both terms are going to be negative. So think about it. Does 5 and 3 add up to 8? It does, but we would need a -5 and a. So this is going to factor into what over here? What are we going to write? Okay, x minus 5, x minus 3. All right, how about this part? X squared minus 5x. Anything fall out there? X times what? Okay, here we go, kids.
I have a question.
Yeah.
So, since it had 2x up there and 2x on the bottom, would it like make it messy if you just cancel those out right away?
Absolutely very messy. Yep, you don't want to do that. Yep, yep. You've got to factor stuff, okay? You've got to group stuff together. All right, once I've factored everything, you see stuff that's going to start falling out top to bottom anywhere. What's gone?
X minus 3.
I see x minus 3 is gone. X minus 5 is gone. Now, right here, this is really 11 times x, isn't it? And the bottom's really 3 times x now, isn't it? What are the x's going to do to each other? They're gone. What are you left with?
11.3.
Wowzers. I'm going to get you set up on 6. I want you to finish 6 on your own. For Tuesday, we'll finish 7 when we come back to get us revisiting here. But how would I write this as a times problem first, kids?
6x squared plus 4x minus 2 over 5x squared times 5. Sorry.
Nope, you're fine. Times what?
Times by 1.
Yeah, we want the reciprocal of this, and in fraction form, that's over 1, right? So times 1 over what, P?
2x squared plus 2x. Yeah.
Okay. So what I'd like you guys to do is to try and factor, each part of the rational functions, see what cancels out, and get an answer for that before you get back here on Tuesday. Fair deal?